chemistry. This is part 2 of 1.13, properties of substance, and I'm just going to start again at the beginning of the slide because I wasn't watching my time on the last recording. Chemical changes occur when substances interact with each other. When an iron nail gets wet and is exposed to air, the surface of the nail rusts. Rusting is a chemical change or reaction where iron, abbreviated Fe, in the nail combines with oxygen, O2, from the air to form rust or iron oxide, F2O3. The ability to oxidize is a chemical property of iron. So the fact that it can rust is a chemical property. Okay, we're going to stop there and we're going to go over a few things in this paragraph. Iron is abbreviated Fe. Why? Because it is actually called ferrous or ferric in either Latin or Greek. So basically this is one of these substances that people knew about since the beginning of people pretty much, and so they already had a common name for it. So then when chemists came along and organized everything in the periodic table, they used the abbreviation Fe. Oxygen. How many atoms of oxygen do I have here? 2. So in the air, we do not have single atoms of oxygen floating around. The reason for that is because they're highly reactive and they really want to share electrons. We're going to talk about that part more later in the semester, but just so that you know, it's O2 because it's already combined with another oxygen atom, and that's the form that it takes. And then it becomes F2O3. So when they come together, how many total iron atoms are there? 2. How many total oxygen atoms are there? 3. So this one molecule is made of 2 iron atoms and 3 oxygen atoms. Consider gold and sodium. Both are shiny metals, but they react differently in water. If you place gold in water, nothing happens. However, if you place sodium in water, it reacts violently and explosively. Pause here. It starts on fire. Yes, when you put sodium in water, this is what happens. It starts on fire. If you put it in a glass beaker, if you put a piece smaller than a dime into a glass beaker, it will make the glass beaker explode. If you put a chunk of sodium into a 5-gallon pail of water that's approximately the size of a pickle, it will shoot about 60 feet of the air and rain down fire and start the lawn on fire. I may have had that happen. That being said, don't get too excited. You can't get that big of pieces of sodium. Even as a high school teacher, they don't sell them like that anymore because it is so crazy dangerous. So, yep, don't bother Googling it. Even I, as a science teacher, can no longer get such huge chunks of sodium. All right, the ability to react with water is a chemical property of sodium, but not of gold. And again, it's chemical. You have fire. Anytime you have fire, think chemical, and it's changing it into something else. And I just added these examples to our chemical property, rusting and sodium exploding when put in water. Chemical changes can be recognized through observation. So how can you tell when a chemical change has occurred? There are several indicators that a chemical change might have occurred. Color change. Careful. There are times when a color change is physical, like when you put food dye in water. So color can be both, or either. Gas is given off, so bubbles. Energy is given off. Temperature might increase, an explosion might occur, or sound, heat, or light might be released. Energy is absorbed, so what would that be called? Endothermic. Temperature might decrease, or a precipitate forms. Precipitate, a solid that forms as a result of a chemical reaction between 2 aqueous solutions. In other words, you put 2 liquids together and one of them turns chunky. Although these signs can indicate that a chemical change has occurred, they are not exclusive to chemical changes. For example, when you heat yellow potassium dichromate, it turns from yellow to orange but returns to yellow when you cool it. Think about a nail, or if you've ever gone to like the Renaissance fair, when you have somebody who's smelting metal, right? And they heat it up red hot, but then when it cools off, it's still iron, it's just in a different shape. So the heating it up and turning bright red is a physical change. So under chemical property, I added the other examples. Color change, careful as sometimes color changes are physical changes like red hot iron. Gases given off or bubbles. Energy in or out, endothermic or exothermic in other words. Sound, light, or a precipitate forms. Precipitate, a solid that forms as a result of a chemical reaction between 2 aqueous solutions. In other words, Two liquids are combined and chemically change, leaving a chunky solid. It's not always chunky, but usually it looks pretty chunky. You can ask questions to distinguish a chemical change from a physical change. When distinguishing a physical change from a chemical change, ask yourself several questions. Numero uno, was there a change of state? Phase changes are for physical. Numero dos, were there any indicators of a chemical change? So was there a gas liberated? In other words, bubbles. Energy given off. Did it get really hot? Or was there a color change? Again, careful on the color change. 3. Was the material chemically the same before and after the change? So if you started with a piece of paper, did you end up with a piece of paper? Yes, physical. No, you burnt the piece of paper and now you have ashes, chemical. Was the change reversible? Many physical changes are reversible, while chemical changes generally are not, although they can be, so be careful on that. For example, if you place pennies in vinegar, a weak acid, the acid reacts with the copper to form copper solution and hydrogen gas. Look closely at the pennies in the jar. You can see small hydrogen bubbles forming on the pennies. This is a chemical change, like right there. Hydrogen gas is released when pennies dissolve in a weak acid. So in our notes, I added the distinguishing characteristics. Was there a change of state? Then that's physical. Were there any indicators of a chemical change like bubbles or heat or light? So then that would be chemical. Was the material the same before and after? Physical. Is it different before and after? Chemical. Was the change reversible? Many, but not all, physical changes are reversible, while chemical changes generally are not, but can be. Okay, that's important. All matter has definite properties and can undergo chemical and physical changes. All types of matter have unique physical and chemical properties that allow you to distinguish one kind of matter from another. Physical properties are features that you can observe or measure. Physical changes do not change the composition of a substance. Chemical properties have to do with how substances interact with one another and can only be observed when a chemical change occurs. Chemical changes change the composition of substances and may be indicated by changes in color, gases given off, precipitates formed, or energy given off or absorbed. Do you remember what precipitate means? Put two liquids together, they chemically combine, and you get a chunky solid. This word's going to come up a lot this year. Many physical changes are reversible, whereas most chemical changes are not. Matter has unique physical and chemical properties. Matter undergoes physical and chemical changes. All right, that's it. Bye.